All right, so here's a think, pair, share activity, which is an opportunity for the student to look at a previous example as a model to try and solve a problem on their own. And you'll notice that in the think, pair, shares, I do not include the calculator screenshots because during an exam, you won't have those either. You'll have to have practiced this enough that you already kind of know what functions on your calculator you need to go to and what values you need to put into those functions in order to uh, get the answer to complete the solution to the problem. All right, so let's look at this one. Um, Pause the video and resume after you've given this a try. But let's go ahead and take a look. So, randomly selected statistics students participated in an experiment to test their ability to determine when 1 minute has passed. 40 students yielded a sample mean of 58.3 seconds. Assume that the standard deviation of the population is 9.5 seconds. Construct a 95% confidence interval estimate of the population mean of all statistics students. Based on the results, is it likely that their estimates have a mean that is reasonably close to 60 seconds? All right, so let's take a look at what we've got. It's always worthwhile to look at our given information here. Let's see here, randomly selected students participated in a test, 40 students. Okay, so that means we have a sample size of 40, yielded a sample mean of 58.3. So a sample mean 58.3. Assume that the population standard deviation is 9.5. So sigma is 9.5. Construct a 95% confidence interval. So because we have a 95% confidence interval, that means the confidence level is 0.95. Based on the results, is it likely that our estimates have a mean that is reasonably close to 60 seconds? Okay, we'll kind of interpret that towards the end. It's always not a bad idea when you're given a confidence level to go ahead and calculate what the significance level is going to be. And so in this case, the significance level, what do we need to add to the confidence level to add up to 1? We need 0.05. And if we were to divide that by 2, what's 0.05 divided by 2? 0.025. So it's kind of good to have those significance levels already calculated it out. Okay. So let's look at what we need. We need to construct a confidence interval that looks like that. Now, we've already got the sample mean part of it. What we need is error. All right, so in order to calculate the error, there's a relation with error, and that's a z alpha 2 score times sigma divided by the square root of n. Okay, sigma, we've got, n, we've got. What we need is this z alpha 2 score. So to get that z alpha 2 score, let's draw the distribution here. Now, since we're dealing with confidence intervals, this is going to be two-tailed. And this critical value and this critical value will be our positive Z alpha 2 score and our negative Z alpha 2, or yeah, Z alpha 2 score. All right, we have a confidence level of 0.95. So our confidence level is equal to 0.95, which is this area here. And the area in each of these tails is going to be the significance level divided by 2, which we calculated earlier to be 0.025. That's that area, and that's that area. All right, so what we need is we need the Z alpha 2 score. Now I'm going to calculate this one on the right-hand side just so that it'll be a positive number and we won't have to worry about it when we go and plug it in here to calculate our error. So we need an inverse distribution function on the calculator to convert an area into a value on the horizontal axis. So to convert it into a number. So let's come over here and let me quit out of that. So I want to go to the distributions functions, go to inverse norm, enter. The area is going to be 0.025 with a mean of 0 and a standard deviation of 1. And I'm going to look at a right tail. Okay, I'm going to leave this up. So I can do the same thing here with the numworks calculator. So I'm going to click on home, go to distributions, and let me back up to make sure I'm in the normal distribution. A mean of 0, standard deviation of 1. And I want the area to the right. So I want the third option. And this will be an area of 0.025. So I've hit execute there. And on the Texas Instruments, execute twice. Okay, I get 1.959664. So I'm going to put here that I calculated a value. So here is Z alpha 2 score. Oh, what did I just say? 1.960. All right, like that. So now I need to take this value of 1.960 and plug that into this equation. So I'm going to have 1.960 times sigma, which is 9.5, divided by the square root of 40. So I'm going to go ahead and put this all in the calculator that way. May have to come back to this screen. Okay, so I'm going to use this answer. All right, and so to use a previous answer, you'll notice it says ANS in blue. I can hit second and this negative key, and it'll put answer. This is an alternative to storing it in a variable if I want to do it that way. And then I think I can just put left parentheses. And then I'm going to put 9.5 divided by the square root of 40. So 9.5 divided by square root of 40. And notice that the cursor is inside the square root. If I want to come outside of that to put my right parentheses, I need to hit the right arrow once. And you can see now the cursor is not underneath the square root symbol. And now I can hit right parentheses. That should give me an answer. There we go. So let me do the same thing here with the numworks calculator. Except what I'm going to do here is I'm going to select this and I'm going to hit Shift and this var key to copy. Okay, now I'm going to go back home, go to the calculation app. And let's see here. I'm going to put left parentheses. I'm going to hit Shift and the toolbox key. That'll paste. Right parentheses. Now left parentheses. And I want to do 9.5 divided by square root of 40, like that. And I'll hit the right arrow key once. That'll kind of get me out of the square root, but I need to hit it one more time in order to get me outside the fraction. And now I'll hit parentheses. And if I execute, it gives me the same answer. So 2.944 and some change. So for the error, I get 2.944 and some change. Remember, our goal, now that we have the error, is to actually make this confidence interval. So the confidence interval is going to be x bar plus and minus e. And x bar was 58.3. That's going to be plus and minus our error, which is 2.944. Okay, now this particular form of the confidence interval isn't going to be helpful so much with our answer. It says, based on the results, is it likely that their estimates have a mean that is reasonably close to 60 seconds? So kind of what we're being asked here, the question is a time of 60 seconds within our confidence interval? Okay, so what we need to do is we want to construct this now on a number line, and we want to know what the upper bound is and what the lower bound is. Well, the upper bound is going to be the mean plus error, and the lower bound is going to be the mean minus error. So we want to take 58.3 and add 2.944 to it. So we want to take 58.3 and add the error to it. And we get 61.244. So 61.244. And if we did the same thing with subtracting, so if I took 58.3 and subtracted the error, I get 55.355 or 356. 55.356. And so where is 60 seconds within this interval? Just waiting for this to switch to black. Okay, so where is 60 seconds? Well, 60 is going to be between 58 and 61. So you can see 60 is within our 95% confidence interval. So put here, set a star. Let me put our answer. So that 60 seconds is within the 95% confidence interval. So yes, the estimates have a mean, which is reasonably close to 60 seconds. Okay, so this concludes this think, pair, share. Let me know if you have any questions.